Okay, so unfortunately in class we didn't get to cover this material, but it's really important for next week. So I'm going to cover like what a LoRa is, how other customizations happen, because as you've probably seen, like if you look at Run Comfy, you'll see there's a ton of models available, and you're like, well, what if I want to make my own model? So I'm going to talk through like the various techniques that exist to allow you to customize an image model. Specifically, I'm going to focus on like sort of a couple different techniques. But the main one I actually want people to learn about is LoRas, because LoRas are kind of like what everyone uses. They're cheap, they're efficient. We'll cover all that. And my goal is that people can train their own LoRa this week or next week and begin to use it in Run Comfy, in Comfy UI as soon as possible. So when we ask about like how do we customize a model, there's actually like a ton of context that I would sort of need if someone were to say like I want to train my own model. Like how do I do it? First off is scale. Like how often are you going to do this? Do you want to train one model that does everything? Are you cool with training a bunch of little models? Like, how do you like? What do you need? And then it's need. Like, some people tell me they're like, oh, I can't get this particular look with this model, and it's like, well, are you using enough prompting? Are you using Clip Interrogator? Are you using other tools? Like, what's the real need about how far off this model is? I often need to know what your technical skills are because a lot of these things do require some level of technical ability, understanding of training tools, like understanding of Python, like those sort of things. And then often it's access to data. How many images do you have? If you don't have like 10,000 images, I wouldn't recommend like training a model from scratch. If you only have 10 images, like you need to look at a LoRa. If you've got 100 or 500 images, maybe there's something you can do in between that. But the amount of data you have is really important. Next is your budget. That is both in money and in time. A lot of people, especially like years ago when I was doing a lot of work with people on AI stuff, they'd come to me and say like, "Oh, I need something like this, but I need it in a week." And I'm like, "Well, I can't train a model for you in a week. Now I could probably train a LoRa for you in a day." But a lot of it comes down to, okay, I need to prep the data, I need to train the model, we need to debug it, we need to test to make sure it's working, I might need to run it again. Like if you only have a couple days, I still probably today couldn't even guarantee I could give you something good. But if you got a week, a month, like maybe that's something we can talk about. Then it's like, how much money do you have? Training a model from scratch today, like OpenAI or Google or these other big companies do, they're burning through millions upon millions of dollars. And most of us don't have that money, so we need to think about what works for us and what sort of budget we have. I'll talk about all these things as we go through each potential type of training as we talk about this. So if you've never seen a network model before, this is what a network model looks like. It's basically like these are your inputs, these are your outputs, and this is all of the parameters inside of it. Often when you see something like, I don't know, ChatGPT has 7 billion parameters, what they mean is the number of nodes or like, little dots inside this model is 7 billion. So imagine this like scaled up like crazy. And what we really want to talk about when we do talk about training is we want to talk about how do we affect what's happening inside this model. The output matters a little bit less. The output matters a little bit less. The input matters a little bit less. We really want to figure out how we train the inside of this. And that's really the key of what we're talking about when we talk about training a model. People always want to jump to like, let me train something just like OpenAI did. And it's like, you don't want to do that, but we can talk about it. So this is what we call training from scratch. This means you are building your own network. You are starting with no one else's model and you are training from original data. And I'm just going to be blunt. You don't want to do this, especially with today's models. A couple of years ago, if you want to train a style game model, I could have taught you how to do that. And training might take 2 weeks, 3 weeks, 4 weeks. And all you need is maybe 2,000 images. Today, with our the current models, you need hundreds of thousands of images. You need 1,000 GPUs, and you need $1 million easily at the start. So, a lot of this is just outside of our realm of possibility. And this, what I mean by training from scratch is like you are literally recreating every one of these nodes in a model from scratch. And that process is lengthy. It takes a lot of time, it takes a lot of resources, it takes a lot of data. There are people out there who would do it. They're often very technical. It's fun to learn. Like the guy who just made Auraflow talks a lot about his process of like learning how to make stuff. He had read every paper, he sort of understood it, but he didn't really understand it until he went to make his own model from scratch. And he had a lot of fun doing it. He learned a lot. He's like shared a lot of those resources. But I guarantee you that anyone watching this video right now probably cannot do this themselves. I can't do this myself. And so, it's fun, but it's like these models take forever to learn or forever to train. We're talking months, years in some cases. a lot of data. We're talking about like, hundreds of thousands of images. They're extremely expensive. I think Google said they spent something like $2 billion on their Gemini tools, like in the first like 6 months of building them. You and I don't have that money at all. And honestly, they really won't ever be as good as models from large AI companies. Um, the guys that made Auraflow, it was just a handful of people, and they had some resources, maybe not millions of dollars, but enough. Like their first release is definitely not as good as, say, Stable Diffusion 3. But it's getting better, and they learned a lot, and they're experts, and they will probably create some really good models in the near future. But it's really hard for you or I to say we're going to make a model that competes with, Stable Diffusion or, DALL-E or whatever. Just not feasible with our time, money, energy, expertise. So again, don't do this. Yeah, if you're following along in this video, just don't do this. Next is what we call fine tuning, and I would say actually fine tuning is probably something that some of you folks watching this video could achieve. It's really something that I could do, and if you have enough technical knowledge in, say, Python or scripting, you could probably do it. By fine tuning, what we mean is it's the process of taking another model, say taking Stability's SDXL, and altering those nodes just enough to change the data or to change the way in which that model works. When you look at the load checkpoints feature inside of Comfy, and you see that there's a bunch of different models that are all available that are, say, like Juggernaut XL or Photogasm or whatever it's called. Those are fine tunes, meaning they took the existing original model, let's say Stable Diffusion XL, and they added their own data on top of it, and that changed the model as it was working. So essentially what you're doing is you're taking all of these nodes inside of the model, and you're sort of like updating what we call the weights. So that means you might bias more towards anime, or you might bias more towards like cyberpunk kind of look. And that's what we call a fine tune. And there's often different techniques of this. Like usually what people do is they do what's called freezing a layer, which are like, these are the base layers, meaning these make like very basic shapes. And they only alter like sort of the end nodes, which are more the details or the coloring or the stylistic things. But these techniques are all mostly available to you today. And while there are some platforms that are starting to come out that allow you to do this without any scripting or technical knowledge, I would say most people need some technical knowledge to be able to do fine tuning. The cool thing is that it is a new model. You're making a brand new model that is very different from the existing like fine-tuned model or from the base model. It's less expensive. I'm not going to say it's cheap, but it's less expensive than training from scratch. The downsides of these things is that they can dramatically change the existing models. So let's say I've got Stability SDXL. When I go and fine-tune that model and say I train it on just flowers, it might now make flowers better than the SDXL model did, but it can't make people as well as the SDXL model it did. So there's also this kind of like push and pull of like, how much do I want to lean into like this new style that is different from sort of like, I'm going to destroy the original model. I'm also going to get back a model that is, in the case of SDXL, like 6 gigabytes. That is a lot of data to move around, and if I'm constantly using new platforms, I have to like download it, upload it, like move it around. It's going to be kind of annoying. And while fine-tuning is less expensive, it still has some price to it. Often it takes a week or two to train, and if you're doing that on a hosted service, they're certainly going to charge you for that time. So it's not cheap. We're talking maybe hundreds of dollars, which is better than thousands or millions, but it's still not cheap. And then I should also mention, like, it still requires a lot of data. Not nearly as much as training something from scratch, but I would say a good fine-tune is still like 5,000, 10,000, 20,000 images. And often those images have to be captioned. Who's going to do that work? Are you automating that work? Is the automation good enough? Like, there's a lot of question with fine-tuning. So in general, I still shy people away from fine-tuning unless you really know what you're doing or really excited to dig into this. I would say fine-tuning is probably best for companies where they have a couple engineers who are maybe data scientists or who are machine learning people, but they're not OpenAI, right? They're not going to be able to like create something from brand new from scratch, but maybe they have their own use case. So in the case of an LLM, say you're a company that works in legal documents and you have access to all this legal data that maybe OpenAI didn't, you could say make a fine-tuned LLM that only speaks in legal jargon or only knows legal stuff. That would be a good use of a fine-tune because it's cool. It's fine that you sort of are destroying the underlying use of that model just to get something that is more specialized. So I'd say fine-tuning is like specialization. And there's a lot of reason to do that, but in a lot of cases, it's not as much of a reason to do that as you might think. Next, we're going to talk about performant fine-tuning, which is like a specialized version of fine-tuning. And this is what you'll see commonly referred to as LoRAs. Now, today there are like a million things called LoRAs. There are things called Q LoRAs, H LoRAs, like other things. I'm going to sort of talk about this in an abstract, high enough way that it's at least just talking about fine-tuning in a way that is LoRa-like, or like something like we would describe as a LoRa. And in these cases, this is actually not a brand new model. It's actually like a little plugin. Like I think of these as like like a little VST plugin that allows you to do something new in your platform that you weren't able to do before. So this does not actually change the original model. What it does is it provides like sort of this extension to it, and the extension then says, hey, in your model, like change stuff in this way to get out a image, or to get out images in a certain style or in an object or a person the way you want it to. This is kind of where a lot of stuff is moving to. And the reason it's all moving to this is like these are much more portable files. So a SDXL model is, I believe, like 6 gigabytes, maybe 8 gigabytes, depending on all the bells and whistles inside of it. A LoRa that is trained on SDXL is like 300 megabytes at most. Much, much smaller files. And it's also possible to have multiple LoRas for different tasks. So you can see this as like really fine-tuned specialization, right? So now instead of that like legal model we're talking about, it's like, oh, this only knows housing law, or this only knows, New York State law around renting or something like that. So it's like much more fine-tuned, much more narrow focus. But also these things are way easier to train. Like there are now tons of services out there that will do this for you, and it takes like an hour or two and maybe $10. So this is like the direction that everything is headed to on sort of the consumer level. And this is what I would recommend people do. And the reason I like this too is like when we look at something like Comfy, we'll be able to load in a base model, and then we'll be able to load in any LoRa that is attached to that base model. And this is the one kind of tricky part of this thing is like, let's say we have a base model of SDXL, and let's say we have 10 LoRas that are all trained on SDXL. We could easily hot swap these LoRas with very little effect. These are 300 megabytes. It's easy to load them. It's easy to share them with your friends. It's easy to pass them around different networks. And as long as they're all trained on the same base model, it's easy to reuse them. And this is kind of why people are moving toward this LoRa practice, because it's just really easy to use them, and it's really easy to make one of these, like an hour, a handful of images, maybe 10 to 20 images, and you can train a LoRa that you can then plop into Comfy and use it, as quickly as the same day. Look, they're not always as good as fine-tuning, and they can break sometimes. There's often moments where they don't work as well as other things. I often find that sometimes I have to train them a couple times. There's enough noise and chaos in these sort of fine-tuning tools where your first run might not look very good. Then your next run is better, and then your third run is really good. Or honestly, sometimes you get a first run that's really good, and then your third run is crap. And it's kind of like, a rolling of the dice to determine how good these are. But I do find you can get pretty good results in most cases. So for image models, like this is what I would recommend. Like, don't look at anything else but LoRas to start with. Once you've made like 10 or 15 LoRas and you're like, I actually want something bigger, I want to be able to do all these things with it, then you might step up to like a more normal fine tune. But LoRas are just so easy to use, and they're honestly so fast to train, and they cost so little that like you can experiment in a way that you can't experiment with other tools. And it's fun to just like figure out what works and what doesn't and play with stuff. So just a lot of fun to work with, in my personal opinion. So we're gonna start with LoRas. I already have some tutorials on LoRa's LoRa generators you can use online. They cost anywhere from $5 to $30, and with varying level of detail and quality, but in general they're all pretty good. Before we jump into like training, there are some requirements for the data set you have. LoRa's operate in a couple different sections. You can think about LoRa's as a way to input your face or a friend's face into the model with pretty good quality. They've gotten the face LoRa's up to like pretty decent quality in terms of being able to inject your face and have it look like you. In those cases, you just need a small number of images, maybe 5 or 10. Maybe you shot outside, inside, from different angles, that sort of thing. Next is objects. You can train an object LoRa. So say you have a radio that's really unique looking and you want to put that in all of your scenes. You could train that, again, with 5 to 10 images. The last LoRa is style LoRa's. And there's really no difference between all these things except how it's trained. The parameters, the training parameters are different, but they're all still LoRAs, and they all still more or less kind of do the same thing. A style LoRa is more like an aesthetic. So say you've got a cinematographer who lights things in a certain way, and you want to approach that style, or say you've got a painter you really like, or say you've got your own artwork that you want to inject into these tools. You might train a LoRa on your own style and then be able to make that usable in these tools. In those cases, you might want a little bit more images, 20 to 50 images, or maybe a little bit more than that. Style is also kind of a hard concept to think through. So like, I wouldn't necessarily combine multiple painters unless they all have a very clear, similar style, like Cubism or something, Some of the platforms we're going to look at today have a limit on how many images you can upload. So for example, Eden.art, you can only upload 20 images for their LoRa, but I find their LoRa trainer is really good. Then you've got something like Civitai, which I think you can upload. I don't even know if there's a limit on Civitai. Might just charge you more the more images you upload. And that's true for Dreamlook, which is another tool we'll look at. So the more images you have, the likelier your data set's going to be better, but also the longer it's going to take to train and the more it's going to cost. So I would say between 20 and 50 images is really what you want to shoot for. If you have 20 images that are all of a very clear looking similar style, you're probably set. I would say like less images but more of a consistent look is better than more images where the look might be more diverse, right? So like this is a case of if you got 20 good images from one artist, use that instead of like 20 images from one artist, 10 images from another artist that kind of look the same but not really, and then a bunch of random shit. Like don't pad your data set for LoRAs. Keep it as consistent as you can, and that's the best way to work. There are LoRAs out there that will work with 2 to 3 images. I think there are other tools that we'll look at later in this class for single images or double images. So I'd say like 5 to 10 is like your minimum size for LoRAs. Next thing we need to talk about is resolution. I'll talk about this again when we talk about base models, but you kind of train a LoRa on a base model. So you need to know what the base model's resolution dependency is first. If you're going to train an SD 1.5 model, your resolution is 512 by 512. I believe that's true for SD2 as well. SD2 might have a 768 as well, but most people just tend to train on either SD 1.5 or SDXL. Those are the two that most people tend to use. So SD 1.5 is 512 by 512. SDXL is 1024 by 1024. I would assume most of us have images of at least that resolution, so it probably doesn't matter as much here. If you're grabbing some really low-res internet images, then you might be stuck with an SD 1.5, but that's kind of up to you. So the important thing to remember is we are always training on top of a base model, and you kind of can't mix and match base models. So once I've trained a LoRa that is trained on Juggernaut SD 1.5, I don't really want to swap it out to an Anime 1.5 model. It's just not going to work as well. It's going to be kind of broken. So in a lot of the platforms we're going to look at, you actually have to choose the model you're training on top of. And choose wisely, because if you have, say, a bunch of anime images, you don't want to train on top of a photorealistic model. It's kind of more work than it's worth. If you have anime images you want to utilize as a LoRa, then you want to use an anime base model. And a place like Civitai, which allows you to basically pick from all of their models, is really good. That's a good place to start. Other tools have a limited set of base models you can pick from, but you can still pick from them. Eden, for example, Eden only trains on top of Juggernaut XL, which is still a great model. It's a very good model. But if you want an anime look, you might be better off training on Civitai, where you can choose an anime base model. There are a lot of tools that allow you to train on top of multiple models. So for example, Civitai, you could train on top of 1.5 and an XL and an SD3 and an SD2 and some of their other custom models. You could basically make a LoRa for your particular style that works across any model. And that's good because in some cases, when we look at like stuff like animation, for animation, you really need to use Stable Diffusion 1.5. All the tooling sort of works off 1.5. But that's for video. Let's say you also want to have some stills in your data set or stills in your outputs. You might want to train an SDXL model on your styles for just images. So again, they're so cheap and they generate so quickly that it's kind of in your best interest to just train a bunch of them and see what happens. You might find that SDXL has more detail. SD 1.5 captures shapes well, but it's kind of blocky and smudgy otherwise. But it's still good to try and experiment with all of them. Again, it tastes, for Civitai, it's like $2 a model. You can choose from any one of their models. Like, it's kind of worth it to experiment. Okay, so I have a bunch of tutorials here. There actually is a Dream Look tutorial. I'll add a link to this as well. For the cloud GUIs, I kind of recommend these three. I really like Eden Art. Eden Art's like trainer is really nice. It also adds this thing called textual inversions, which we're not talking about here. Maybe I'll cover it in a later video. But that makes your style outputs really, really good. The downside of Eden is, even though it's free, you can train your first LoRA through them for free. To export your LoRAs to something like Comfy, you have to pay for their $30 a month plan. I'd love to see that change, Gene and Xander, if you're listening. But yeah, you do have to pay for that. You could pay for 1 month, export your files, and then cancel your subscription. I think it's worth it. I pay $30 a month for all of their tools because I really like them, and I really like their trainer. So if you're really interested in like the best quality, I would kind of say Eden is the best quality. Civit.ai is, I assume at this point everyone knows Civitai. They just recently launched a model trainer that's pretty good. The downside is you got to use Civitai, and the downside is if you want a custom model, you got to wade through all those young girl models, which is a little annoying. But I think for cost and for quality, it's probably the way I would go. So if cost is a big deal for you, Civitai is cheap. It's super cheap. It's like $1 a model, maybe $2 for an XL model. The other one that I've used before and I kind of like it is called DreamLook. The downside of DreamLook is, one, just not a lot of people use it. Two, you need to provide captions manually. So what I've done in the past, I've used Civitai, I've tagged my data with captions, and I've exported from Civitai back to DreamLook to train on there. Who knows? It's a lot of work. So I would say DreamLook is like the last one, but if you're really interested, there's some nice stuff there that you can do with DreamLook. Outside of cloud GUIs, there are a bunch of tools available to you. Koya, Kohya, is the most popular sort of trainer for both LoRAs as well as fine tunes. And there's a way to run it on Colab if you're a Colab person. I've yet to record a tutorial. I probably will this week. But there is a bunch of tutorials online. I linked to one of them here if you want to watch that. And then local only, if you have a local GPU and you really want to train just locally, the best one, the one that most people are excited about right now, is called One Trainer. I would say Koya up until very recently was sort of the go-to, and One Trainer has kind of like started to take off and been a little bit more of the go-to, and people are kind of excited about that. I will probably record a tutorial about that, maybe not this week because it's a lot of work, maybe next week or in the near future. I linked to a 2.5-hour tutorial on how to use One Trainer. It's like the Bible on One Trainer. If you really want to watch it and dig in, you can. I would say, Koya is fine. Koya is very, very good. But One Trainer is like the next step over if you really want to get into it. So I'd say start with Koya if you're really going to do local, or if you're going to use Colab. Okay, that's it for this week. That's it for this session on LoRAs. In the syllabus, I've also linked to these 3 tutorials on how to use these GUIs, as well as these other tutorials that I didn't make. So your mileage may vary, but I think they're okay. And I would definitely recommend, if you're going to just do one tool, just use Civitai. It's the cheapest, it's decent quality, it's pretty easy to use, and there's a 15-minute tutorial on how to use it. If you want the best quality and you don't mind spending a little bit of money, I would say Eden is the way to go. And if you just want to compare all of them, then I would say like use DreamLook as a comparator. So next week, what I'll probably do is I'll record a little video on my comparison. I tried to train on the same data set across those 3 tools, and we'll upload them and we'll look at them and we'll see what the results are. And then next week, we'll also look at how to actually just upload these and load them into your own tool. So hopefully by next week, everyone has a custom LoRA they've trained themselves. And then we're going to upload it to run Comfy or to your local instance, and we'll run it and we'll see how it looks on the output. Because there's some nice features that we can do by playing with the strength of the output or whatever through Comfy. But it's just fun to be able to train your own style tool and sort of see if you can generate your own styles or get something more interesting out of them without having to deal with other people's models. Cool. So ask any questions in our Slack channel or of me once you've started training, and I'm happy to help with people as well. So we'll see you next week then when we start to load these in.